Okay, so let's look at another problem. Can we use the integral test for the following series? So this isn't even asking us to do the full integral test, it's just can we use it? So we're going to start with let a sub n equal f of x, which equals x divided by the square root of 2x minus 5. So now we need to check for our three things: positive, continuous, and decreasing. So if we look here, x over 2x minus 5, well, our denominator is a square root, and we can't have a square root that just comes out as a negative value because it's not a negative square root. So the denominator is going to be positive. We're plugging in numbers bigger than 3, so we know that we are going to be positive for everything. So f of x is positive for x greater than or equal to 3. Continuous. So the big thing is we just need to double check that our square root doesn't kind of cause us any problems. 3 is our smallest number, so if we plug in 3, 2 times 3 is 6, 6 minus 5 is 1, so we have the square root of 1. That's not going to give us a negative, and if we get bigger values of x or n, we're still going to be fine. So we know that f of x is continuous for x greater than or equal to 3. And then our last part, just double checking that we have the derivative. So we have f prime of x equals u prime times v. So we have the square root of 2x minus 5 minus the derivative of the square root, so something to the 1/2 power. So we have 1 over 2. If we take the derivative of the 1/2 power, we get this 1/2. And then it becomes to the negative 1/2 power, so we have the square root of 2x minus 5 in the denominator, because it would be negative 1/2 goes to the denominator back to a square root. And then we're going to multiply this by 2x, so instead of the 1, we're going to go ahead and put a 2 here. And then we're multiplying this by x, so I'm going to go ahead and put an x up there too. This is all divided by the square root of 2x minus 5 squared. So we need to kind of simplify this down so that way we can get something that's going to be workable for what we need. The first thing I'm going to do is make common denominators on the top. So I need to multiply the first fraction by 2 square root of 2x minus 5. If I multiply the square root of 2x minus 5 by itself, that's going to leave me with 2x minus 5. And then we're multiplying that by 2. The denominator, we have something square rooted and squared, so we get 2x minus 5. Let's see, we get 4x minus 10. If we distribute it, and then if I combine my two fractions, we're going to subtract 2x. This gives us 2, the square root of 2x minus 5, divided by 2x minus 5. We have 4x minus 10 minus 2x, so I'm going to go ahead and do 2x minus 10. And then looking at this, I can actually also factor out a 2 from this, 2x minus 10, to get x minus 5. And then I'm going to change the dividing by 2x minus 5 to times the reciprocal of 1 over 2x minus 5. And then we're going to go ahead and simplify the best that we can. So we're going to have an x minus 5 on top. And we're going to divide it by, square root is to the 1/2 power. This would be to the first power. So we're going to have 2x minus 5. And then if we add those powers together, we get the 3/2 power. So what we want to decide is what's going on with this function right here. So the 3/2 power part, we're going to have a square root, but we're also going to have a squared or a cubed. And that's going to kind of change whatever sign we're working with. If I plug in a number that is less than 5, so say 3, because 3 is the smallest number we've been working with, 3 minus 5 is going to give us a negative on top. 3 times 2 is 6. 6 minus 5 is 1, so this is going to give us a positive on bottom. Because we're multiplying our number by 2, the denominator is going to give us a positive every time. It just depends on what the numerator is giving us. And because we have x minus 5, our numerator is only really going to give us a negative when we are between 3 and 5. So f prime of x is negative or less than 0 for values between 3 and 5. And we are positive for values bigger than 5. So what this means is we are not decreasing the entire time. And because we are not decreasing, the 3 criteria are not met. Which means we cannot apply the integral test.